Today we're looking at balancing equations with moles, and we're also looking at limiting reactants. So, have we heard of the word limiting reactant, or maybe from biology you've heard of limiting factors? Have a think about where you've heard those terms and what those terms mean. So, when we do experiments, quite often there are two reactants involved, and it's very common for one of them to be in excess. We have more than we need of it. So, why do we do this? Why do we commonly have one of our reactors in excess? And there's a number of reasons for this. It could be that it is readily available, so think oxygen in the air when we're combusting things. It could be that one of the reactants is really expensive or in short supply. And this is going to make sure if we have something in excess that is fully utilised, all that reactant is used up. So let's think of an everyday example of a limited reactant. So we think of peanut butter sandwiches here. If we presume that we need to have 2 slices of bread for our sandwich and we're going to put a tablespoon of peanut butter in, well, if we've got a jar of peanut butter and we've got 8 slices of bread, we can make 4 sandwiches and we're going to have some peanut butter left over. If we change that scenario around a bit and we've got our 8 slices of bread but only 1 tablespoon of butter, we're only going to be able to make 1 sandwich and have 6 slices of bread left over. So in this case, the peanut butter is our limiting factor. That is determining how many sandwiches I can make. So let's add some chemical examples now. So we have some carbon here, and we're going to react it with some hydrogen, and we're going to make some methane. So I've got 8 carbons, and I've got 24 hydrogen molecules here. So we've got 48 hydrogen atoms, if I separate them out. So if they react together to make methane, I can make 8 methane molecules, and I'm going to be left with an excess of 16 hydrogen atoms. So in this reaction, my limiting reactant is the carbon. That is controlling how much product I can make. Again, another chemistry example here, we've got some nitrogen and some hydrogen gas inside our container. So we're going to have a reaction called the Haber process here, where we have hydrogen and nitrogen reacting to form ammonia. And in this scenario, there is nothing in excess. Every single hydrogen molecule and nitrogen molecule is reacted to form that ammonia. But in a different reaction, we might have some excess. So in this one, we have excess of nitrogen gas. And if we've got it in excess, that must mean that the hydrogen is limited. So let's look at some examples you might see. So question 1. When 5 moles of sulfuric acid react with 7 moles of calcium, what is the moles of product formed when one of the reagents is used in excess? So when you get one of these questions, you want to be systematic in how you approach it. So A, write down a simple equation for this reaction. Then identify the ratio of the moles. Then identify which reactant is in excess, explain your answer, and then you can say how much product is formed. So pause the video, have a go at this, and then we'll go through the answers. So, writing down a simple equation. We've got sulfuric acid plus calcium forms calcium sulfate plus hydrogen. This is our following our rule, acid plus metal makes metal salt plus hydrogen gas. So what's our ratio? These are all in a 1:1:1:1 ratio, which makes it pretty straightforward. So then which one is in excess? In this case, because of 1:1 ratio, if we've got 5 moles of sulfuric acid, that's all that will react, okay? So sulfuric acid is our limiting reactant, and that means that our calcium is in excess. So there's going to be 2 moles of calcium which don't have any sulfuric acid to react with. And that means, in terms of products, we're going to form 5 moles of calcium sulfate and 5 moles of hydrogen. Because they react in a 1:1:1 ratio, sulfuric acid is our limiting reactant. That is going to determine how much product we have. Let's have a look at another question. When 3 moles of calcium react with 2 moles of oxygen, What is the moles of product formed when one of the reagents is used in excess? So, write a simple equation, what are the ratios, identify which reactant is in excess or limited, and then say how much product is formed, given a reason. So let's go through this one. We've got calcium react with oxygen to form calcium oxide. I'm going to balance that to make sure I've got the correct number of calcium oxygen on each side. They're in a ratio of 2 to 1 to 2. So that means 2 moles of calcium will react with 1 mole of oxygen to form 2 moles of calcium oxide. So, only 3 moles of calcium can react. So we know that, and we know that we have oxygen available in excess in the air around us. So, in this case, calcium is a limiting factor. So how much calcium oxide we're going to form? It's going to form, because it's a 2-to ratio, in this example, if we've got 3 moles of calcium reacting, we're going to form 3 moles of calcium oxide. So there are 2 methods when looking at calculations for limiting reactants. So method 1, write a balanced equation. Then for each reactant, calculate the amount of product formed. Then the smaller answer will indicate the limiting reactant, and therefore the amount of product that will form. Method 2, begin by writing a correctly balanced chemical equation. Write down all the quantitative values under the equation, including units. Convert all reactants to units of moles. Divide by the coefficient in front of each reactant. And the smallest value is the limiting reactant. I'm going to go through a few examples now, so make sure you have a good worked example in your notes. So, slight change of topic now. We're going to look at using moles to balance an equation. So we've looked at balancing equations, and we look at the ratios of the different atoms, and we've adjusted those accordingly. Another method we could use is using the moles that based on the quantities we have of the different reactants and products. So let's go through a worked example. A student reacts 1.2 grams of carbon with 16.2 grams of zinc oxide. The resulting products are 4.4 grams of carbon dioxide and 13 grams of zinc. Determine the balanced equation. So your first step is write down and work out the relative atomic or molecular masses of each substance. So work out your MRs. So carbon is 12, zinc oxide is going to be 81, carbon dioxide 44, zinc 65. So you're using the mass numbers, the top number on our periodic tables. Calculate the moles of each substance using the formula moles equals mass divided by MR. So we're given the masses in the question, we've just worked out the MR, and we should get these numbers. So carbon is 1.2 divided by 12, which equals 0.1. Zinc oxide is 16.2 grams divided by 81, which equals 0.2. Carbon dioxide equals 4.4 divided by 44, which equals 0.1. And zinc is 13 divided by 65, which is 0.2. What you're then going to do is divide across by the smallest number which appears, in this case 0.1. And we're basically trying to get the ratio of these to each other. So if we divide all these numbers by 0.1, we get carbon 1, zinc oxide 2, carbon dioxide 1, zinc equals 2. So then we can use those whole numbers to put into our equation. So 1 mole of carbon will react with 2 moles of zinc oxide to form 1 mole of carbon dioxide plus 2 moles of zinc. If you want to write the 1 before the carbon and the CO2, that is perfectly acceptable. Etiquette has that we find that we don't need to do that, but sometimes it can be helpful to remind you that there is 1 of that thing there. So if you're in my class and you have been set this task to do, you'll find a sheet on Show My Homework for you. And I'd like you to go through using the 4 steps we've just discussed and balance some equations using this method. If you aren't in my class, you'll see the questions on the next bit. Ta-da! Here they are. So, go through step 1 equation, mole calculation, simplify the ratios, balance the symbol equation for all of these. Pause the video please and have a go before checking the answers. And there they are. Use a nice green pen if you're in my class to mark those. Well done.